Hello everyone, my name is Fadi Boutros from Fraunhofer Institute in Darmstadt, Germany. We propose in this work a novel face image quality assessment approach, CR-FIQA. The proposed CR-FIQA estimates the face image quality of sample by learning to predict its relative classifiability. This classifiability is measured based on the allocation of the training sample feature representation with respect to its class center and nearest negative class center. As such property is only observable for the training dataset, we propose to learn this property by probing internal network observation during the training process and utilizing it to predict the quality of unseen sample. Before we go into details with our proposed approach, let's look first what is face image quality and why do we need face image quality. Face image quality indicates the utility of an image to automatic face recognition algorithms, and face image quality estimator should answer how utility is sampled for face recognition system. Current face recognition systems perform highly accurate under controlled conditions. However, under unconstrained environments, they have to deal with large variabilities, leading to degradation in recognition performance. Thus, the performance of biometric recognition is driven by the quality of its samples. Estimating the utility of sample for automatic recognition has several advantages. For example, it is needed to achieve robust enrollment of subjects in biometric system, for more secure negative identification system, and even to enable quality-based fusion approaches. Face image quality is evaluated by plotting ERC curve and calculating the area under the curve. ERC plots the percentage of neglected data of lowest quality on the x-axis versus the biometric verification error on y-axis. As we seen here in this plot on the right, that the quality estimators in red and green lead to lower verification error when rejecting a fraction of images of lowest quality in comparison to the blue one. Here we have an overview of our proposed CR-FIQA. During the training phase of an face recognition model, the model can conventionally push the high quality samples close to their class center and relatively far from other class center. On the other hand, the face recognition might not able to push to the same degree low quality samples to their class center, and thus they will remain relatively farther from their class center than the high quality ones. Based on this assumption, we theorize our approach by stating that the properties that cause a face sample to lay relatively closer to its class center during the training are the ones that make it a high quality sample, and vice versa. Therefore, learning to predict such property in any given sample would lead to learn to assess this sample quality. The predictions of such training paradigm can be simply stated as answering a question. If a given sample was hypothetically part of the face recognition model training, which is not, how relatively close would it be to its class center? Answering this question would give us an indication of this sample quality. We propose in this work to simultaneously learn to push sample to their class center using margin penalty softmax loss, while learning to predict the certainty ratio of sample, which is the ratio of class center angular similarity to the closest nearest negative class center angular similarity. Once the model is trained, the output of the quality regression layer can be used to estimate the quality of any given sample. To evaluate our proposed approach, we propose two models, CR-FIQA S and L. The model S is trained on relatively smaller database, Cassia WebFace, using ResNet 50 network architecture. And the model L is trained on MS1 million using ResNet 100. We evaluate our proposed approach using 4 different face recognition models and on 8 different evaluation benchmarks. We have here the ERC curve for IGBC benchmark using 2 face recognition models. The proposed CR-FIQA L and S are marked with solid blue and red lines respectively. Ours outperform all state-of-the-art face image quality methods, as CR-FIQA lead to lower verification error when rejecting a fraction of images of lowest quality in comparison to the state-of-the-art method. We also evaluate in this paper the use of the quality score as an embedding weighting term. And here we have in this table the verification performance on IGBC using 1-by-1 mixed verification protocol. And as we see here, that CR-FIQA outperform all state-of-the-art methods under all settings. To ensure the reproducibility of the research results in this paper, all training and evaluation codes, as well as the pre-trained model, are publicly released. With this, I finish my presentation. For more information, please visit my paper that is on Tuesday, PM poster number 163. Thank you for listening.